Hello, how are you? So we'll start Python. You like China? Place this.
What? Place this where?
No, I'm not telling you. Go. Just wait a second.
Mama.
ये ले जाइए कम क्या नाम है बैठ के रखते हैं. So now we'll do Python. So let's start.
भैया look at it.
Okay. So we'll do हो जाए. नहीं छोड़.
Welcome back, everyone. In this lecture, we're going to discuss the flow This is where we really start to be able to construct logical programs.
So let's
Okay, so it's an exciting leap. Let's head to the Jupyter Notebook and get started. All right, let's begin with a simple example. I'm going to create a list called my list, and we're going to set this equal through the numbers 1 through 10. We'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, and then finally 10. And as a very quick note, you should not use list as a variable name here. Notice that it's being highlighted through syntax highlighting. That means list is a built-in keyword, so avoid using just list by itself as a variable name. If for some reason you accidentally already did that, go ahead and delete this, and then just hit kernel, restart, and then restart this, and that will reset all your variable names. What you will need to do is then rerun some cells. Rerun that. Notice how now it's back at 1, so I've restarted everything. Okay, so I have this list, 1 through 10. Now I'm going to create a for loop to iterate for every item in this list. So I start with the keyword for, and then I get to choose a variable name that's going to represent the elements inside of this list. So we're going to say for num in my list, that iterable, colon, I hit enter, and notice now how I have an indented block of code there. So now I can interact with those actual elements. So let's print them out. I'm going to say for num in my list, print num. And then when I run this, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's actually printing out this number for every number in that list. Something I want to make really clear, though, is that this particular variable name that you chose to represent the elements inside that list, it can be whatever you want. So here, I chose num because these are numbers, but I'm going to just make it really obvious by choosing jelly, and then saying for jelly in my list, print jelly. Run that again, and you get back the exact same results. So again, this variable name can be whatever you want. This iterable has to be predefined. But this variable name that's going to represent the actual objects inside that iterable, that is whatever you want. Now I also want to show you the point that we technically don't even need to use this variable name. We can still execute some block of code for every single item in this list, even if the code itself is unrelated to the item. So I can print hello for every item in that list, and we get back hello 1 through 10 times. And again, we can call this whatever we want. Num, run that, and we get back hello 10 times. So keep in mind, when choosing these variable names, you have full flexibility. So you want to choose a variable name that's Now let's combine our knowledge of for loops with a little bit of what we just discussed in control flow. Let's see if we can print out only the even numbers in this list. So to do that, what we're going to do is start off by saying for num in my list, and then I'm going to add in some control flow to somehow check if the number is even. So I'll say check for even here. This is just a comment. And then what I will do is the following. I'll say if num mod 2 is equal to 0, colon, print the number. So what I'm doing here is I'm saying, okay, for every number in that list, if the num mod 2, so remember, that's the remainder when you divide by 2 is equal to 0. So if there's a number and you divide it by 2, the remainder is 0, then you can go ahead and print that number. So then when we run this, here we have all the even numbers, 2, 4, 6, 8, 10. And I can add even more control flow by attaching an else statement to this if statement, and then say print odd number. And we can even do some f-string literal formatting, so I can say if odd number, right there, run that, and it says odd number 1, 2, odd number 3, 4, odd number 5, 6. So this is some good work here as far as combining for loops with the control flow from before. Key things to note here is the indentation. So luckily, Python is very clean because of the use case of indentation. So everything at this indentation level is inside of this for loop. So this entire block of code is going to execute every single number in that list. And then we can see that this print num is only going to execute when this if statement is true. And this else indentation is lined up with this if. So we say if, in this case, print num, else, and then we print out the odd number. And again, using some string literal to print the number itself. All right, let's move along. So another common idea for a for loop is to keep some sort of running tally during multiple loops. And later on, we're going to show you the enumerate function, which kind of does this for you automatically. Right now, what I'm going to do is say list sum is equal to 0. So let's try to get the sum of every number in that list. So I will say for num in my list, I will say the list sum is equal to the current list sum plus the number. And then I'm going to, outside of this for loop, print out the list sum. So when I run this, I get back 55. So this is a good example of indentation and a use case. So right now, I have this list sum. So I'm saying my initial sum is 0. Then for every single number in that list, I take my old value for my sum, and I add on the current number, and I reassign that value to list sum. So I do that over and over again for every number in that list. And then at the end of this for loop, once it's done completing, so notice the indentation level here, I print out list sum. Let's see what would happen if I were to press tab here and have this print statement inside this for loop. Now when I run this, I get back kind of the running tally of this sum. So it starts off at 0, and then once it has its first run inside of the for loop, it gets printed out. So then it has 0 plus 1. Well, that's equal to 1, so it prints out 1. Then we have 1 plus 2, 1 plus 3, and it prints out 3. 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, and so on. So now we get the running tally, and it's only until the very end that we see 55. If we only want to see the last result, then I just have this print outside of that for loop. So that's why indentation in white space is so important. So we just saw how to use for loops with lists, but what about strings? Remember, strings are a sequence, so that means we can iterate through them, and we'll be accessing each character. So for letter in, and let's create a string. We'll say my string is equal to hello world, letter in my string, colon, print out that letter. And I run this here, I can see HELLO space WORLD. So that's the way we can actually iterate through a string itself. And technically, you don't need to actually assign a variable name to the string. What you can do is just straight up put the here. So it could say for letter in hello world, print letter. And we get back the exact same results. And I really want to drive this point home. You can call this whatever you want. So this letter variable name, you can say ch, and as long as it's the same thing inside of this, and you run this, you'll get back the same result. And the other thing I want to stress is that you technically don't even need to use this variable. So a lot of times what people do as they get more advanced in Python, for some reason they want to iterate something a certain amount of times. So imagine I wanted to print cool for as many times as there are characters here. So I see cool. What they do is instead of assigning this variable name, they just use an underscore. And that's really common syntax for when you don't intend to actually use that variable name as you iterate through. So they just use a simple underscore there. That way it's a little more readable. Okay, so that's iterating through a for loop. You can also use the same iteration for a tuple. So I could say tup is equal to 1, 2, 3. Then for item and tup, print out the item on that, and I get back 1, 2, 3. Now, I want to mention tuple unpacking. So tuples have a little bit of a special quality when it comes to for loops. So if you're iterating through a sequence that contains itself tuples, the item can be used with tuple unpacking. So let me show you what I mean by this. I'm going to create a new list called my list, and I'm going to set this equal to a list of tuples. So here I have square brackets, and I'm going to make some tuple pairs. We'll say 1, 2, comma, and 3, 4, comma, 5, 6, comma, 7, 8. So notice what I have here. I have a list, and then there's tuple pairs as items in that list. So if I check out the length of my list, I have 4 items in it, where every single item is a tuple pair. So let's print out those items themselves. So for item in my list, print out the item. And when I run this, I actually see themselves. 1, 2, 3, 4, 5, 6, 7, 8. This sort of data structure is extremely common in Python. And later on, we're going to see that a lot of built-in Python functions actually take advantage of this built-in structure and return back tuples inside of a list. And the reason for that is something called tuple unpacking. Right now, we had to print out every single item inside this tuple. But what I could do is the following. I could say, let me delete this print statement. I could do the following. I could say for, and make kind of a temporary variable that looks like a tuple here. So for A, B in my list, then I can print the variable A, and then print the variable B. So note what happens now. I'm saying 1, 2, 3, 4, 5, 6, 7, 8. So what's actually going on here? It's called tuple unpacking, where you kind of duplicate the structure of the items, in this case tuples, inside of this sequence, and then unpack them. So now I have access to the individual items. So if I only want to print out the first item in those tuples, so I run this, I get back 1, 3, 5, 7 because now I'm only printing A. So this is known as tuple unpacking, and technically you actually don't need these parentheses here, so it's a lot more common to see it done this way with no parentheses. So now I say for A, B in my list, print A. Let's see what happens if we print B. We should get back all those even numbers. So that second half, that 2, 4, 6, 8. So again, this is tuple unpacking. And you're going to be using it a lot as you start working with functions, because a lot of things pairs and sequences in this manner. I'll show you one more example. Let's say my list is equal to a list 1, 2, 3. 1, 2, 3. Well, let's make it something numbers. Say 5, 6, 7, and we'll do one more with 8, 9, and 10. I skipped the number 4 here, but no big deal. We'll say 4 item in my list. Print item, and there are my 3 tuples. But I can do tuple unpacking here. So the way I can do that is make up 3 variable names, separate them by commas. So I can say A, B, C. Notice I don't have to use parentheses, and then I can print out whichever one of these I want. For example, if I just want to print out 2, 6, and 9, those middle numbers, I would just say B, and there we go. We have access to B, so just the middle numbers. So this is really useful when you want to reorganize these structures into some other manner, or maybe you only want to deal with the first item in these tuple pairs. Okay, so that's tuple unpacking, and now let's finish off this discussion about for loops by discussing how to iterate through a dictionary. So to do that, we're going to create a dictionary called D. We're going to have K1 as a key value. We'll have the number 1 as that value. We'll say K2 here, colon 2, and then we'll say K3, colon 3. And then I'm going to, for item in D, print the item. So this is something that's kind of interesting. Notice that by default, when you iterate through a dictionary, you only iterate through the keys. So K1, K2, and K3. If you actually want to iterate through the items themselves, what you need to do is call items here. And now when you run that, you get back these tuple pairs, K1 of 1, K2 of 2, K3 of 3, which means we can use the same tuple unpacking technique we just discussed. So instead of items, what I can do is say key, comma value, let's say I want to print out the value. Then I can say for key value in D.items, print out the value, and then I have 1, 2, and 3. Again, you manage the tuple unpacking here. Because D.items returns back something in this sort of format. And more likely it's this sort of format, we have a key and a value. We're using the same tuple unpacking that we just discussed, now with D.items. So by default, when you iterate through the dictionary, it's going to be keys. If you want to iterate through the items, you can use tuple unpacking, grab both keys and values. If you only want the values themselves, what you can do is say D dot, and then call values off of this, run that, and it'll only print out the values 1, 2, 3. The last thing I want to note here is that dictionaries are technically unordered. This is a very small dictionary, so it looks like everything's going in order, 1, 2, 3, K1, K2, K3. But if you have a very large dictionary, there's no guarantee that things are going to be sorted or in any sort of order. So keep that in mind. When you iterate through a dictionary, there's no guarantee that you're going to get things back in the order you put them in. So now we've learned about how to use for loops with tuples, lists, strings, and dictionaries. It's going to be a really important tool for us, so make sure you understand well of the above examples. Specifically, make sure you really understand the white space. So probably the most important thing to get out of this lecture is the fact to use this for keyword, any temporary variable you want, say the keyword in, some sort of iterable object, either values, the list, or a string itself, as we saw up here, colon, and then in this indented block of code, that's going to execute every single time for every single iterable in that list. Thanks, everyone. And if you have any questions, feel free to post them in the Q&A forums. I'll see you at the next lecture. Welcome back, everyone. Let's now take some time to talk about while loops. While loops will continue to execute a block of code while some condition remains true. So, for example, if we try to relate this to a sort of real-life scenario, while my pool is not full, maybe I want my program to keep filling my pool with water. Or if I'm designing a robot with some code, while my dogs are still hungry, keep feeding my dogs. Let's explore the syntax of the while loop. It's actually quite simple. We're going to say while, and then some sort of Boolean condition. So we usually have some sort of comparison operation check, and a lot of times it's going to be while some variable is true or equals true, and then colon, and a block of code. And that block of code, in this case represented by do something, is going to continue to execute while the condition is true. And we can also combine a with statement with an else statement if we want. So we can say while some Boolean condition is true, do something else. Meaning once that condition is no longer true, or since the beginning it was no longer true, we do something different. Let's explore these concepts with some examples. Alright, so let's start off by building out a very basic while loop. I'm going to create a variable, say x is equal to 0, and then say while x is less than, let's actually say less than 5, so we have to hold out printing. We're going to print the current value of x. So we'll say print the current value of x. Lots of different ways we can do this. We'll just do it quickly with an f-string literal. The current value of x is, and then inside curly braces we'll pass an x. Now let's imagine what's going to happen here. Don't run this cell yet. We'll say x is equal to 0, while x is less than 5. I'm going to print out the current value of x. So if I were just to run this, basically I would say the current value of x is 0. And that would happen over and over and over again, because x isn't changing. So let's update x during this while loop. We'll say x is equal to x plus 1. So now let's run this and see what happens. I get back the current value of x is 0, then 1, then 2, then 3, then 4. Now that last one, when it's equal to 4, we then say, okay, x is equal to 4 plus 1, which makes x equal to 5. 5 is not less than 5, it's equal to it. So then the while loop stops running because it's only going to run while this condition is true. Now, if you accidentally have some sort of condition that never becomes false, maybe you forgot this last line of code here and you just read over and over and over again. So what happens is you get an infinite while loop, and it's a common mistake for beginners to make. I know I've made it myself a bunch of times when I was learning Python. What happens in the Jupyter Notebook is you get a little star here indicating that the cell is still continually running. In order to kind of reset things, just come over here to kernel and either hit interrupt, and if that doesn't work, then hit restart and restart your kernel. Sometimes interrupt won't work because basically the command to interrupt won't get there because Python's using all your computing to kind of continue this while loop. So keep that in mind. If you ever get an infinite while loop, just go over here to kernel and then hit restart, and you'll have to redefine some cells again, but that's the basics of avoiding that error. Okay, so we have the while loop by itself, and as a quick note, this statement of x is equal to x plus 1, we can also write that in the following manner. We can say x plus equals 1. So this line and this line are the same thing. This is just a more compact way of writing it. So if you're ever reading someone else's code and they wrote this instead, that's kind of a sleeker way of writing that same code. Let me write this once again. I can say now into, we get back the same values. Let's attach an else statement to this while loop. So we can say else, colon, and I'm going to print x is not less than 5. And now we run this and see what happens. We get the current values, so all those other print statements, and then I see x is not less than 5. So once this while condition is not true, because this else is lined up with it, we went ahead and printed x is not less than 5. Now, as a quick note, if right off the bat, x was greater than 5, so let's make x equal to 50, and I run this, then this while loop never executes because this condition is never true, and then we have the else condition execute anyways. That doesn't mean I need it, so if I didn't have it there and I ran this, just nothing would happen because this isn't true. Alright, finally I want to introduce 3 keywords that are really useful with loops. You're not going to be using them all the time, but sometimes you'll need their use cases. And that's the break keyword, the continue keyword, and the pass keyword. Break is going to break out of the current closest and closing loop. Continue goes to the top of the closest and closing loop, and then pass does nothing at all. So let's start a little bit backwards here. We'll go with pass, and we can show this actually with a for loop. Might be a little simpler here. We're going to say for, let's make a quick list. We'll say x is equal to 1, 2, 3, and then say for item in x, colon, and let's say we didn't quite know yet what we wanted to do here. We essentially want some filler. If I just have a comment here, and I try running this, so when you attempt to run this, you actually get an error. It says syntax error, unexpected, end of file, parsing. And what that means is Python, because it uses indentation and white space as a crucial part of its code, it expects you to basically have something here. Even a comment isn't enough to fill it. So often what you can do is have the pass keyword, and the pass just says do nothing at all. And a lot of times programmers keep it as a placeholder to kind of avoid the syntax error. Because you can imagine if I'm writing a larger piece of code, and I know eventually want to come up and fill out this for loop. Right now, I don't want to deal with it. Let's go into print end of my script over here. Now when I run this, I don't get that syntax error, and I'm still able to print out my script. If I just have the comments, I get an error because it's expecting something to happen after this. So in order to avoid that, use the pass keyword. And you're going to see the pass keyword used a lot when we start building out functions and methods ourselves, because often when you're programming, you'll create a little holder for a function, but you don't want to test it right away. So use the pass keyword as something to put in place there, so you avoid syntax errors. And you're also safe because you know pass doesn't do anything. It just says, well, I'll pass this, I'm not going to do anything. All right, so that's the pass keyword. It does nothing at all. Continue. Goes to the top of the closest and closing loops. I'll show you an example of that. I'll actually use for loops again for this. we're going to say my string is equal to Sammy. So let's have that there. We'll say 4 letters in my string. Print out the letter. So here we see Sammy printed out. Now what I'm going to do is let's imagine that I actually didn't want to print the letter A for whatever reason. I could do the following. If the letter is equal to lowercase a, colon, continue. And now when I run this, I'm not actually printing out the letter A. So what's happening here? Continue basically tells this program to go back to the top of the closest closing loop. So here's continue, and we have up here 4 letter in my string. So if that letter is equal to A, we continue, meaning go back to the top of the closest closing loop. Note that we are specifically saying loop, we're not saying some sort of statement here. So that's where semantics come into play. But what this is saying is if the letter is A, go ahead and continue and go back to the loop. So that's how you can use the continue statement. If you're a beginner in Python programming, it's definitely not something that comes up a lot in your beginning code. It's going to happen that more naturally you'll start using it much later on. So be aware of it, but don't worry about use cases right now. You won't really be using it that often. And then finally, breaks out of the current closest and closing loop. So let's see what happens if we replace continue here with break instead. Now when we run this, what happens is instead of going back to the top of the closest and closing loop, it breaks out of the current closest and closing loop. Meaning it just breaks this loop and stops this loop if that letter is equal to A. So that's actually really useful, especially with while statements. So let's see an example of using break with a while statement. Zoom in here just so we can see this clearly. I'm going to do the same thing as before. We'll say x is equal to 5, and then we'll say while. Actually, let's make it equal to 0 here, just as before. While x is less than 5, print out x, and then we'll say x is equal to x plus 1. So when I run that, as expected, I get 0, 1, 2, 3, 4. But let's imagine I wanted to break this while loop if x was ever 2. I can do the same thing here. I say if x is equal to 2, at any moment, go ahead and break out of this while loop. Now when we run this, we only get back 0 and 1. Okay. So that's the basics of this break, continue, and pass keyword. So we covered this lecture with the while loop. So while some condition is true, execute this block of code. Be careful here because if you accidentally say while this condition is constantly true, you may have to restart and break out of this while loop. Now when we run this, we only get back 0 and 1. Okay. So that's the basics of this break, continue, and pass keyword. So what we covered in this lecture was the while loop. So while some condition is true, execute this block of code. Be careful here because if you accidentally say while this condition is constantly true, you may have to restart your kernel. If you're running a Python script and you end up getting that error that the while loop is just never closing, you should try Control C. That typically interrupts. So you can even see here, interrupt, Control C to go to the kernel. All right, then we have the break continue here because if you accidentally say while and this condition is constantly true, if you're running a Python script and you end up getting that error that the while loop is just never closing, you should try Control C. That typically interrupts. So here, interrupt, it says Control C to go to the kernel. All right, then we have the break, continue, and pass keywords. We're not going to be using these right off the bat, especially things like continue, but we'll probably be using break a little more, and then once we get used to functions, we'll be using pass a little more, and then much later on, we'll be using continue. But you should be able to use keywords now that you understand both for loops and while loops. Okay, thanks everyone, and I'll see you in the next lecture. Welcome back, everyone. In this lecture, I'm going to discuss a few building functions and operator keywords in Python that didn't really fit well into any of the previous categories. However, they're still really important, and they're going to really enhance your ability to program with Python. Let's open up a Jupyter Notebook and quickly run through these. Let's begin by talking about the range function in Python. Notice that often we were creating lists that were just a series of integers, such as 1, 2, 3, or 1, 2, 3, 4, 5, etc., all the way up to 10. Because it's such a common task, Python actually has a built-in operator for this. And there's two ways you can use it. One is you can iterate through it. So I can say something like for and then we use the keyword range, and it takes a couple of parameters. You can do shift tab here to see the parameters it takes, but basically it has a start, stop, and optional step size. So start is technically also optional. Let's show you how we can actually use these. So if we just indicate a single number, such as 10, and we say print num in range 10, what it's going to do is it's going to generate the numbers from 0 all the way up to, but not including 10. So that all the way up to, but not including, that's very similar to that slicing syntax we saw earlier in the course. So for num in range to 10, print the number, and here we see 0 through 9. Now let's say we wanted to actually specify a starting index position for the integers. We could say start at 3, go all the way up to, but not including 10, and then when we run this, we get 3, and then all the way up to, but not including 10. So that's the range operator. And in addition to all this, we can actually have a step size as well. So we can add a third argument for step size, and that gives us the even numbers. So that's taking jumps in steps of 2 from 0 all the way up to, but not including 10. So if we wanted to include 10 as one of those numbers, we have to put in 11 there, and then we get back 0, 2, 4, 6, 8, 10. So that's how you can use the range function for iteration. But you'll notice if I copy and paste this into a cell and ask for it to be returned to me, I just get back this range operator. And it's because it's a generator. So if I actually want the actual list of numbers, what I can do is cast it to a list, and then I get back the list of numbers. Later on in the course, we're going to discuss generators in a lot more detail. But basically, a generator is just a special type of function that will generate information instead of saving it all to memory. So this is a more efficient way of generating these numbers instead of having a giant list stored in memory. And we'll discuss that in a lot more detail in the generators section of the course. Let's move on to discussing another really useful function called enumerate. And to show you the use case and motivation behind enumerate, let's do an example. I'm going to set a variable called index count equal to 0. Let me zoom in here one level. So I have index count is equal to 0, and then for letter in the string A, B, C, D, E, I'm going to do some printing here. I'm going to say at index, the letter is curly braces. Then I will use dot format here to say index count and then the letter as well. Okay, so what I'm doing here is at index count, the letter is blank. And then what I will do is say index count plus equals 1. So when I run this, it says back the following information. At index 0, the letter is A. Index 1, letters B, and so on, all the way until the end. Now this is such a common operation that what we're going to do is use the enumerate function to replicate this. And the reason this is very common is because a lot of times you will want to have some sort of counter for how many times have you gone through this for loop, or what index position you're at in this particular string. And the reason for that is because often people like to do something like this. They like to, let's define word as A, B, C, D, E, and then say for letter in word, print word at that index count. And then we say index count plus equals 1. So what's actually happening in this loop? Well, we're doing the following. We have an index count starts at 0, and we have a word string A, B, C, D, E. Then for every letter in that word, so for every character here, what we end up doing is we print the index value location at that word. And that's the same thing as printing the letter. But oftentimes what we'll end up doing is using this sort of syntax with a list later on in our code. But in order to do this, we need to have some sort of running index count. So when I run this, I get back A, B, C, D, E. Because this sort of operation is really common later on, what Python did is they built in the enumerate function. So let's see what happens when we use enumerate. So I'm going to delete index count. What we'll end up doing is using this sort of syntax with a list later on in our code. But in order to do this, we need to have some sort of running index count. So when I run this, I get back A, B, C, D, E. because this sort of operation is really common later on, what Python did is they built in the enumerate function. So let's see what happens when we use enumerate. So I'm going to delete index count here, and I will say for item in enumerate word, print out the item. And now when I run this, I get back, notice, tuples. So 0 with A, 1 with B, 2 with C. So this is basically doing that index count for us automatically in the form of tuples. And as we know, word, particular string. And the reason for that is because often people like to do something like this. They like to, let's define word as A, B, C, D, E, and then say for letter in word, print word at that index count.
Turn on this light tonight.
And then we say index count plus equals 1. So what's actually happening in this loop? Well, we're doing the following. We have an index count starts at 0, and we have a word string A, B, C, D, E. Then for every letter in that word, so for every character here, what we end up doing is we print the index value location at that word. And that's the same thing as printing the letter. But oftentimes what we'll end up doing is using this sort of syntax with a list later on in our code. But in order to do this, we need to have some sort of running index count. So when I run this, I get back A, B, C, D, E. Because this sort of operation is really common later on, what Python did is they built in the enumerate function. So let's see what happens when we use enumerate. So I'm going to delete index count here, and I will say for item in enumerate word, particular string. And the reason for that is because often people like to do something like this. They like to, let's define word as A, B, C, D, E, and then say for letter in word, print word at that index count. And then we say index count plus equals 1. So what's actually happening in this loop? Well, we're doing the following. We have an index count starts at 0, and we have a word string A, B, C, D, E. Then for every letter in that word, so for every character here, what we end up doing is we print the index value location at that word. And that's the same thing as printing the letter. But oftentimes what we'll end up doing is using this sort of syntax with a list later on in our code. But in order to do this, we need to have some sort of running index count. So when I run this, I get back A, B, C, D, E. Because this sort of operation is really common later on, what Python did is they built in the enumerate function. So let's see what happens when we use enumerate. So I'm going to delete index count here, and I will say for item in enumerate word, print out the item. And now when I run this, I get back, notice, tuples. So 0 with A, 1 with B, 2 with C. So this is basically doing that index count for us automatically in the form of tuples. And as we know, we have tuple unpacking from the for loop lecture. So I could say the following. I could say index, comma, letter, and then I could print out the index, and then print out the letter separately, and then print out a new line using an escape sequence character. So now I say 0A, 1B, 2C, etc., and so on. So this is the enumerate function, and it can take in any iterable object, and what it does is it returns back some sort of index counter, and then the object itself, or the element at that particular iteration. The next one I want to show you is the zip function, which is kind of almost like an opposite of enumerate. What it does is it zips together two lists. So I'll say my list 1 is equal to 1, 2, 3, 4, 5. I'm going to make...
Mama, do I have it?
List 2 equal to A, B, C, D. Actually, let's just do A, B, C, 1, 2, 3. That way they match up. And then what I will do here is zip them together using the zip function. Now, if I just run zip, I don't get back anything. It just says, hey, you have this zip generator waiting for you at this location in your memory. If we actually iterate through it, so if I say for item in zip my list, and then I print out the item, notice back we get back this list of tuples. So previously in that for loop lecture, I mentioned that tuple unpacking is going to be a really useful thing because a lot of built-in functions in Python return back a list of tuples, and this is one such function. The zip function will, just like a zipper on a jacket, zip together these two lists and pair up these items so that they match together. And you can actually do this with more than just two lists. So I could say
Mama, Sol has come out.
Set this equal to some digits here. We'll say 100, 200, 300. And I can pass in this as another thing, my list 3. And now I can see the output is these tuples of 3 items. A common question is what happens if these lists are uneven? Well, we can check that. Let's add in a bunch more elements to the first list. So we're going to say 4, 5, 6 here.
Channel.
Now when we run this,
It
we
is
actually
channel.
get back the same results. So keep in mind,
You
zip
can go
is
live
only
in
going
it
to be able
too.
to go and zip together
Video.
as far as the list, which is the shortest. So it won't give an error. It'll just ignore everything else.
My
that's
one,
extra.
I'm not using it. Was
You
came
see
now.
here that we iterated
How
through
do
the
you-
zip, but if you
what do
actually
you
just
mean
want to
it
get the list
came?
itself, you can just cast it using list. So we can say
I will
list
log out.
of
Don't
zip,
log into everything on
and then we'll
Google.
put these lists together.
I
खबर
told
भने
you
ना पेगा।
yesterday.
1A, 2B, 3C.
So, oh,
Alright,
self
that's the zip
thought.
operator.
What are
Very
you doing
useful
on
for
stream
zipping
here? Why are
together
you going
two
live?
lists if you want to later use them
Shall
together
I close
using
all the
tuple
things?
unpacking. So as I mentioned, you could unpack these. So I could say A comma B comma C and maybe just print out B here
I'm
and I
not
only get back the
discouraging
letters.
you from doing the YouTube
Now I
channel.
want to show you
Just-
the in operator.
If
It's
you
pretty
have-
basic, the in keyword during the for loop, but we can use it to quickly
Yes,
check
if
if an
you're
object
using
is
someone
in a
else's
list.
content, it will be mine.
I can say is X in the list 1, 2, 3, and I'll return back a boolean true or false. Is it in 1, 2, 3?
Yeah,
I can
content
also use
detected,
it
that is what I tell
or a list of
you.
letters. So for example, let's now say X,
Google
Y, Z,
Hamza pe shan harakatuna ma kawa.
and now it returns true because X is in that list. So this is a really nice way to quickly check if something is in a list. So now let's
Don't
change
give
this
access
to
to anything.
1, 2, 3, and it gets back true.
The
The in keyword also works on other iterable logic types, so it works in
None of
strings as
my
well.
Don't
You can
think
say
you're
is
too
A
smart.
in,
You're not smart. ChatGPT
world.
knowledge is not real
and it
knowledge.
returns back true. This also works in dictionaries as well for their keys. So I could say my key, and then check